Hello everyone, this is Azim Ansari, Assistant Professor at Shri Vileparle Kelavani Mandal's Institute of Pharmacy, Dhule. Today I am going to discuss about buffers. Introduction of buffers. Buffers are an important concept in acid-base chemistry. Then what is the buffers? Buffers are compound or mixture of compound which due to their presence in solution it resists to change in pH after addition of small amount of strong acid like HCl or strong alkali like sodium hydroxide. Then buffer action. The resistance to change in pH is known as buffer action. Then buffer solution. The solution whose pH is not much altered by addition of small amount of strong acid or strong base is called as buffer solution. Then definition of buffers. Buffers may be defined as it is the solution of electrolyte which do not change their pH on addition of small amount of acid or alkali, standing for long period of time, exposure to atmospheric condition, and doesn't change on dilution. That is the definition of buffer. It is electrolyte which do not change or which resist their pH on addition of small amount of acid or alkali, standing for long period of time, exposure to atmospheric condition, and doesn't change on dilution. And types of buffers. First one, acidic buffer, a solution of containing mixture of weak acid and salt of its conjugate base in water is known as acidic buffer. For example, acetic acid is a weak acid and salt of strong base. Strong base, here sodium hydroxide is a strong base and its salt is sodium acetate. Acetic acid and sodium acetate. Then basic buffer, a solution containing mixture of weak base and salt of its conjugate acid. For example, ammonium hydroxide is a weak base and ammonium chloride is a salt of strong acid. Here hydrochloric acid is a strong acid. Then third one, double salt buffer. Buffer system containing two salts. For example, potassium dihydrogen phosphate and dipotassium hydrogen phosphate is the example of double salt buffer. The fourth one, single salt buffer. A solution of a single salt of weak acid and weak base in water. For example, ammonium acetate. It is a single salt of buffer. Weak acid here, acetic acid and ammonium hydroxide is a weak base, which combined together it form single salt buffer. Then mechanism of buffer action. What is the mechanism? How buffer solution resists to change in pH. When a strong acid is added, for example hydrochloric acid, protons are shifted by the salt of component of the buffer system, and similarly when an alkali is added, means sodium hydroxide acid component will get deprotonated and the alkali combine with the proton to form water. For example, acetate buffer is made up of acetic acid and sodium acetate. Acetic acid and salt of its strong base, sodium acid. Here we have get the example of acetate buffer system. First one, when a strong acid like HCl, hydrochloric acid, is added to a solution, HCl is added into this solution which containing acetate buffer system. This acetate buffer system, sodium acetate get converted into acetate and sodium ion. This acetate this acetate ion combine with the proton which is released by hydrochloric acid into the solution. This H plus ion increases into the solution. It combine with acetate ion of buffer system and get converted into acetic acid, and through this way it decreases the H plus ion concentration. This acetate ion combine with H plus ion and it converted into acetic acid and decrease the H plus ion concentration in the solution, and through this way it resists to change in pH of the solution. Similarly, when a strong base like sodium hydroxide is added, when a strong alkali like sodium hydroxide is added in a solution which containing acetate buffer system, sodium hydroxide is added into this solution which containing acetate buffer system. It increases the concentration of OH minus ion into the solution and disturbs the pH. At that time, acetate buffer system acid like acetic acid get dissociate into acetate ion and proton. Proton means H plus ion, and this H plus ion combine with OH minus ion increases concentration of OH minus ion in the solution and get converted into water molecule, and through this way it decreases the concentration of OH minus ion in the solution. The remaining part of strong alkali sodium ion is combined with acetate ion and it converted into sodium acetate, and through this way it resists the change in pH, or the change in pH is very small. Then role of buffers in pharmacy. What is the application? What is the role of buffers in pharmacy? First one, solubility. It pH play an important role in solubility behavior of many drugs and pharmaceuticals in API system, in active pharmaceutical ingredient. Many inorganic salts such as salt of ferric phosphate are soluble in acidic medium but precipitate in alkaline medium. Then color. The color of many natural dyes, certain synthetic drug has been found to be pH dependent. For example, red color of cherry and raspberry syrup is maintained at acidic pH, which becomes pale yellow at alkaline pH. Then third one, analytical laboratory. The buffer of known pH are used as a standard to calibrate the pH meter. Then stability of compounds. Certain drugs or pharmaceuticals are stable at a particular pH value. For example, adrenaline is a drug is rapidly oxidized by dissolve oxygen to adrenochrome in an alkaline medium. Hence, its pH stabilized by using a buffer of pH range 2.5 to 3. Then patient's comfort, injectables and preparation for internal or external use become irritating if their pH is greatly different from that normal for the particular tissue involved into parenteral. An extremely acidic or alkaline pH must be avoided because of possible tissue damage. Thank you.